right? So you should understand that we're performing a regression here, L1 and L2, X, Y, which means that whatever the first is goes into the X value, which is time, and then height in feet. Also, let's enter our already have everything. So, but at first you would have probably, why did I clear it? I could have just, anyways. First you go zoom 9, and that's what I would recommend, right? You get your scatter plot. You can tell this is a quadratic, not just because of the scatter plot, also the context, right? You're throwing something up, coming back down. So there we go. And then you justify that. Scatter plot indicates a turning point, a max, a quadratic function would best model the scenario, or something along the way, along this line here. So you got 1. Here's what I would say. If you said cubic, let's say, or linear, you would get a -1, but the province would still honor what, like if you say linear, you actually perform a linear regression, even though it's like way off, we would still get you the mark for your regression. So don't leave that blank if you're not sure. So I'm going to go ahead and perform the regression. I already did that. I had just a warning here. This happens actually more often than you think. You got to make sure it says L1, L2, L3, because sometimes students by mistake delete one of those columns, but they don't realize it. They just, it's like, oh, what happened? And it just, like, let's say L1 is gone, and they just enter everything into L2 and L3. The regression won't know what to do. Like, it will look for L1 and L2. So remember, it's stat and setup editor. Run that. If you run it, it will bring back any column you may have deleted. That's probably a good reminder. Anyways, I'm going to run my regression. And here we go. There it is. And there's no ease, so you got to watch out for that. I made that mistake last week. Don't miss that. The province, I would say for the most part, tries to make sure that doesn't happen, but I'm not going to guarantee that. Okay. So here we go. These are my coefficients rounded to 2 decimals. So you would probably have 0.87. I usually write down 4 or so on my keys to see if you go more than 2 decimals, and at least I know what it's supposed to look like. But 2 decimals is just fine. Unless, I will repeat, unless they say they have done round to 3 decimals. Right? So then you have to be 3 decimals. And the reason why they say that is because that A would probably be 0 if you rounded to 2 decimals. So you got to watch out for that. It cannot be 0 here. Everything else can, but not that. Anyways, what's the maximum height here? We use second trace max. So again, this would be based on your equation. And the maximum height is 124.38. Are we good on that? Because I rushed on my key this morning. So I thought I had it, but I couldn't find it. The flare ignites, becomes bright 4 seconds after launch. How high was it when it ignites? So second trace value, x is equal to 4, right? This is my time. Plug that in, and then you get the y value, which is this. Okay, so 1 mark for everything. And then it says the flare drops out of sight when it gets 75. So I know I didn't do this right because it dawned on me later. How long was it visible? Here's the key. I'm going to highlight this. So I'm not quite done yet. Because visible is the thing that, so if you get this point, if you have this point, I give you 1 mark, right? If you found that. But visible starts at 4. And then it stops being visible 19.2. So time, delta t in a sense, you go 19.20 minus 4. Because it's a whole number, you don't need to round to 4 decimals because it's not going to affect it. So that'd be 15.20 seconds. Okay, so this would be another mark for that and a mark for that. There we go. So a mark if you get the 19.2. Remember, if this had been dollars, you want to make sure you have that 20. Otherwise, it's okay. Here, I already changed it on the Word document, so if you take this again with me next year, I won't have to clarify. Why would you do that? You crazy? Anyways, so it's from time 4 to 19.2. That's when it stops. And then the range, the lowest height it's ever visible, it's 73.75. That's given to me by D. Right? 4 seconds in, you're at this height. And then the maximum height it ever reaches is 124.38. So 1 mark for each. If you don't have round brackets, I believe it's a half mark deduction. So you need to have square brackets if you do it this way. Okay. If you want the set notation, that's okay, right? You just got to make sure you use the variables that appear on your equation. So whether it's given, if it's given, this could be T, C, whatever the equation has. You have to have that letter if you want full marks. But I would expect you to be able to read these statements and know that that's what it, right? It's telling you the domain and range in set notation. So on this page, 2, 4, 5, 6, 7, 8. So this page is worth 8 marks. Okay, all right, next page. Draft the scenario based on the context. I think you all know what to do here, right? Height in feet, time in seconds, get that out of the way. Don't lose marks for that. And then the biggest x value I need to account for is, let me go peek. I know 16 is over here, 16.81, but remember, these points are just for us to be able to model the path, right? But then we have that extra statement of visibility, like when is it visible? So that's what I want on here. So assume the restrictions and you stated in F are still in place. That is a key here. So the maximum x value, go back to your domain and range, right? You need to count all the way to like in the 20s, I will go. And then for my y, I need to go to the 130s or 140s or 150s, whatever. So you got to make sure you account for that. So let's see here. 5, 10, 15, 20. I have lots of space. I could do less than that, but I'm just gonna go with it. That's okay. There's nothing wrong with it. And then here I would go 50, 100, 150, 200 probably. That's what I would do. There we go. Quadrant 1 only in this case. We're not going below the surface. And so we start at 4, and at 4 we're in the 75s. 73.75, I should say. So just make sure it's just under there. So that would be my starting point. And I'm going to go ahead and find the vertex as well. I feel like that's important. That's 11.65, 124.38. 11.65 is here. 124. This would be 125 right there. So I'm going to go just below it, somewhere in there. And then at the 75 mark, this is 75 right here. I'm coming back down, okay? And that would be at 19.20. So that would be right about there. And if you wanted to put the points that, the other points that are given, 3.161, that one technically shouldn't be on there, but we used it to model. 7.5, 109, you can put that in there, okay, to help you out. And then 10 is 122, so it should be just under the other one here, below the vertex. And then 12.4, that's right about there. That's 123, also just underneath. And then 16.81 is here, 101. So right there. So there you have those points. And then you just go ahead and graph this curve. There you go. And my equation is, just going to read it off of my calculator here, 0.87x squared plus 20.17x plus 6.91. That's the equation there. So if you have all labels, if you have a consistent scale, like the scale is worth a full mark. So if you're off even by a little bit, like if you're not going up consistently, that would be a -1. The shape and the points being in the correct place is another one. And then the labels is another one. So 3 marks right there. Obviously, if you picked a linear, then you would have a straight line. Like so, if you're consistent, you'd be surprised how much you can actually score. Even if you completely get it wrong at the beginning, if you're consistent thereafter, you can score points. Okay. So 3 marks, 3 and 8 is 11. So put that mark up top, your name and last name.